Okay, so I want to give you guys an idea for contour maps. Oops. And a couple words of caution. So first, what is a contour map?
The map that shows the elevation of the land.
So a contour map is one of these things where we do this. We do like X's and Y's, and then there are like curves, and the curves are associated to some Z values. So we might do like Z is 2, and Z is 1, and Z is 0, and some more stuff. And then in here we might have, so I'm saying Z is 3, and here Z is 4, and here Z is 5, right?
That'll be going up and the other lower down.
You guys see this? So this is what? What am I doing that you guys already know how to do, that this is somehow dumber even?
They're associating a height to a given coordinate or place.
Yeah, we're just saying, okay, we're going to cut at heights, and then we're going to draw the height, or the X's and Y's that are associated with that height, right? This is just that same cross-section stuff we were doing just a minute ago, except now it's easier because you're doing only, right, horizontal slices. You're doing parallel to the XZ plane. You guys see that?
XY.
Sorry, XY plane. Yes, thank you. So we're doing parallel to the XY plane slices, and then we're labeling with the Z coordinate. These should, I hope, be easy. This is one of the life skills I want you to have. Looking at this thing, if you are standing, say, right here, where is it easy to go and where is it hard to go?
It's easy to go down.
Z equals 5.
Yeah. So it's easy to go into this thing,
Puts down.
because this is a,
Has
yeah, this is a hole, right?
There's steps.
And it's
Mountains over there.
hard to go that way,
Or at least Heather.
right? Because that's a
Mountain or hill.
peak, right? You guys with me on this?
Yep.
How would you?
How is it to walk along one of these curves? So like, how is this kind of walking?
It's not flat.
Yeah, this is flat, right? So when you look up on a hillside, which happens, God knows, a lot around here,
Yeah.
right? Sometimes you will see these lines out on the hillside. Why?
There's deer trail.
Yeah, because deer often do this, right? They walk on level curves. Cows do this too. They'll walk on the level curve everywhere, right? Because they just want to go around the mountain. They don't want to walk up the mountain or down it, because then they'll have to walk up or down later, right? So they'll just walk on these level curves. Who else does this?
We do.
Yeah, human beings do this like mad. So if you look around here, you'll see all sorts of freaking roads built on level curves in the mountains. And they're not actually roads, they're aqueducts. And they're not quite level, they're just really close. So like, specifically I'm thinking of up by Rainbow Pools. You guys know that canyon below Rainbow Pools?
Is that like in Groveland area?
Yeah, up at Groveland. So there's Rainbow Pools, it's a swimming area, and then there's that like big canyon there. And out of an area just up of Rainbow Pools, there's an aqueduct that Hetch Hetchy maintains. And it brings drinking water to the city of San Francisco. And so if you walk along in those hills, there are doors that just go into the hillside. And if you walk back 50 feet into the hillside, there's a big ass tube in there with water in it. And the reason they're on a level curve, right, is what? Yeah, super easy to build. The water doesn't build up too much pressure, so you don't have to do a really good job with your fittings. You can just kind of cruise it along, and then you can siphon over valleys. You guys know what the siphons look like? The biggest siphon I think I've ever seen is down by Mariposa on 120 before you go up Priest Grade. That whole thing is a siphon. So that's the reason they keep it high through there, so they can build a siphon and get back up to that same level curve on the other
Like
side.
if you try to steal gas or something? Like where you get the flow started.
Yeah, so a siphon, sorry. This is totally aside from contour lines, so I'm not going to do this, but remind me later and I'll do siphons. There's one on campus, we can actually walk up and see it. So level curves are these things about heights, right? So I do want to get a couple of things into your head, which is these guys. So I'm drawing here another set of level curves. Okay. And sometimes, what the heck, I'll add this one. This one doesn't always show up. Okay? Like sometimes it's just in between the contour intervals and you don't see this X. Now, there are a couple ways to interpret this picture, right? Depending on whether the contour lines go up or down in each of these quadrants. I'm going to do this one just for kicks. I'm going to say this is 0, right, on the X. You guys recognize that if they cross, they have to be the same height, right?
Okay. Good enough.
This one's going to be Z is 1 and Z is 2. And this one over here is going to be Z is 1 and Z is 2. And these are going to be Z is -1 and Z is -2. And these are going to be Z is -1 and Z is -2. You guys all good with this thing? I want you to recognize this one. Good. This is a saddle. Why is it called a saddle?
It looks like a saddle.
Yeah, because when you're standing in one, it looks like a saddle, right? Like, if you're standing, I'm going to pretend I'm standing here looking that way, right? So, standing here looking that way, what do I see in front of me? Up. What's behind me?
More up.
Also up. What's to my right?
Down.
Down. And to my left is?
Also down.
Down. That's what it looks like to stand in the middle of a horse saddle, right? Or a bicycle saddle.
Never stood in a small perspective in the middle of a bicycle.
Really? You guys don't do this with yourself? You don't like shrink yourself down and stick yourself on
No,
stuff?
I mean, in
for
my
kicks?
head I've done it, yeah, but I
Yeah,
don't really
so-
consider in my head physically doing things like that. I could be a doctor too.
Okay, well,
But in
we
my
need
head.
to, well, remind me, we'll talk about perception versus reality later. So, anyway, point is, there's another way, there's another thing that could happen here, right? What's the other thing that could happen here? Like, I labeled these, right? If I erase the labels, what else could this represent? Yeah, this could represent this funny kind of crossed valley, right? Where you're standing in the bottom and there's level out in these directions, but it's uphill, 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 uphill,
Yeah.
right? You guys see that?
Kind of be like a highway built through a. Right.
Yeah, this would be like a funny canyon, right? It'd be like where two oxbows came together in a canyon. Like, it's possible. I've stood in them, but it's very strange. Okay. So, I want you to spend at least a little time like putting yourself on these pictures and kind of thinking about what's up and what's down. Here's another kind of useful one. If you're standing, say, here, right? What do you see in front of you?
Need a direction of where we're looking.
Sorry.
In front of you, it's just more flat land, as far as I can tell.
Yeah, maybe if there's another level
Yeah,
curve
maybe
in
there's
here.
more. We're going up.
Yeah, so that's probably in general up, right?
Mm-hmm.
Behind you is in general
Down.
down.
You
So you're standing on this hillside, right? What's to your left and right?
get canyons going
Going
down.
down.
Oh.
So keep in mind, you're standing on a level curve, right?
Yeah.
So it's roughly flattish. You guys see that?
Yeah.
Like I might be a little bit off, but I'm like, this way is flat and this way is steep, right? So that's another thing we're going to have to learn. You can't just check one of the derivatives and be sure about what's going on. You have to check both of them. You guys see that?
I'm having a hard time scaling myself to what I'm standing on in my head, so I'm just immediately putting myself like out in nature on the mountains. That's
Yeah.
a little more realistic.
Perfect. Yeah. So another thing, if you're standing at this saddle, right? let me change the orientation on that saddle a little bit. Let me assume that's one direction and this is 90 degrees to it. I know I haven't drawn that in this picture,
Fair enough.
right? But you're standing in a saddle, right? You're clearly not at a min or a max, right? Because you could walk uphill, right, that way to get up, and that way to get down, right? So you're not at a min or a max. But what's the derivative looking that way?
0.
0. And the derivative looking that way?
0.
0. What's the concavity looking that way?
Concavity.
None.
Oh yeah, none. because-
Yeah, it's also 0, right? Because you're looking straight out on a level curve. What's the concavity looking that way?
0.
None.
Shit. We're going to have to come up with something better than concavity to check for maxes and mins. You guys see
Oh.
that?
Do you use
Oh
derivatives?
man.
We're going to still be able to use derivatives, but we have to be really careful. And that's part of what I want you to get from contour maps. Cool? So checking one derivative is awesome. Checking another one is also awesome. Putting that information together is a little bit subtle here, and checking for mins and maxes is pretty subtle.
Okay, so what about the fact that the level curve kind of curves around the mountain, hugging it? Like,
Yeah,
it's
keep-
not exactly straight off in that direction.
Yeah, so keep in mind, right? Derivatives are instantaneous information.
The
So if that tangent line and this tangent line are at 90 degrees to one another, you're going to get 0 out of both derivatives. You guys see that? There are even weirder situations that can happen. Okay? So there are yet more complicated things you can make where you make 3 of these or 5 of these or 8 of these little things come in together that make all of this a mess. Cool?
Yeah.
So you just have to be careful. You cannot get away with the usual like Calc 1, like check the first derivative, check the second, check, check, done. You have to think a little more. Cool? All right, that's the word of caution I'm going to have. Otherwise, these are just level curves. I really do encourage you to like go do some topographic maps. We're going to go do an activity outside that I think will solidify some of this. Questions, Steels? Okay, cool. Let's go outside.